So an operation that isn't usually thought of as being an operation is what we call compositional functions. Okay, so compositional function can be understood by if you break the word composition down. Okay, so I like to think of the word compost. So made up of different parts. So if any of like grandmas, granddaddies, maybe even mom or dads have like a compost pile or like a manure pile, something like that, right? You take a whole bunch of different things, you mix it together, and you make fertilizer. Okay, so you make up different parts, and then shun just means bring to life, give action. All right, so function composition is symbolically written as this. So f of g of x, which is also equal to I remember like doing this in high school. I would always say fog x. Okay. Important information here. If you look at these dots, they're open. Okay. Dot has got to be open for this to be composition. If it's closed, it's written as multiplication. Okay. So you read it f composed of g, or the result of f. So the result of f, which can be thought of as y, comes after. So the y value of f comes after the y of g. So what you really do is use two functions to create a new function. So you can compose functions about specific points or in general. Now, if you do a specific point, say you have the function f of x is equal to 2x, g of x is equal to x plus 3, and then a specific point, let's just say x equals 5. And you want to compose f of g of x. Again, this is equivalently f of g of x. Okay, so what you want to do is you're going to take x and you're going to plug it into your g function, or the function that's on the right. So g of 5 is equal to 5 plus 3. Again, 5 just took the place of the x on the left side, so what I do to the left, think of I must do to the right, which means is 8. So g of 5 becomes 8. Now you want to take this and go f of 8, right? Because 8 is really the y of g. And you're going to plug the y value of g into your original f of x function. So f of 8 is equal to 2 times 8, which is 16. Specific point, a note about it. Is it's always a number. Okay, so when you compose a function into another function at a specific point, it is always a number. Now in general, so when you just compose a function into another function, it, however, is always a function. And how you do this, and again, I'm going to use the same example, f of x of g of x, where f of x is equal to 2x, g of x is equal to x plus 3. And again, this time, because x is, could be anything, you're going to plug the entire function g of x into f of x. So we'll say f of g of x. And again, g of x took the place of the x on the left of the f function. So what I do to the left, I can also do to the right. So 2, and then x plus 3. And then you just evaluate it. So it'll be 2x plus 6. Right, because I multiplied the 2 to the x, 2 to the 3. Now, some examples. I already have one done. I'll talk through it really quick. If I have f of 3, right, I'm just going to evaluate the function f at the x value 3. So f of x is 2. And again, everywhere I see an x, I replace it with a 3. So 2 times 3 minus 1. So 6 minus 1 is 5. So therefore, f of 3 equals 5. Now, I'm actually going to do a composition. And I'll do f of h of x. So when I do compositions, I like to write what the actual function is. F of x is 2x minus 1. H of x is x squared plus x plus 3. Now, the function on the right, so am I thinking about if I'm doing general or specific point? This one is just in general because I don't have a specific point for the x. So if it wanted a specific point, this x would actually be a number. So because of that, f of h of x is equal to, the function on the left is what I'm actually going to write, so 2. Again, this right here is usually an x, but because it's h of x, I'm going to write the entire h of x function in place of the x. So x squared plus x plus 3 minus 1. I then distribute the 2 to the x squared, and it becomes 2x squared. Distribute 2 to the x, it becomes 2x. Distribute the 2 to the 3, it becomes 6. Then minus 1 is at the end. From here, combine like terms if at all possible. I have an x squared term, linear x, have a 6, and I also have this 1 at the end. So I can reduce it just a little bit more. 2x squared plus 2x plus 5. This last one right here, f of g of h of 0, just work your way right to left, okay? So h of x is x squared plus x plus 3. And again, this is going to be a specific point because of that 0. So h of 0, everywhere I see is x, I just plug in a 0. 0 squared is 0. 0 plus 0 plus 3. So h of 0 is just 3. I then take that h of 0, which is 3, and then it's going to become g of 3. Well, so I come up to the function g of x. So 3 times 3 is 9. So g of 3 is 9. So I've now done this, which then becomes f of 9 is equal to 2. X I'm going to place with g of 3, which was 9. And then subtract 1. 2 times 9 is 18. Minus 1. 18 minus 1 is 17. And this should be my answer. Okay. A little complicated at first. It's a lot of substitution. That's why I said at the very beginning of the video, the more organized you are, the better. The neater you are, the better. If I didn't give you enough space to work here, don't be scared to put this on a sheet of paper and actually give you some room on page 21 if need be.